welcome from my side. I'm Martin. I'm here with my colleague Paolo. We both work as data scientists for KNIME, and yeah, tonight we want to show you how to leverage H2O machine learning with KNIME Analytics platform. Before I start right away, I want to ask you whether you already got in touch with KNIME. Have you ever heard about KNIME before? Please give me a short raise hand. All right, thank you. So I'm gonna leave a couple of words about what KNIME is. So KNIME is the organization behind the open source analytics platform. It was founded in 2008. We got offices in Zurich, Constance, and Berlin. That's where we both are located, and in Austin, Texas. And as I said, the KNIME Analytics platform is our main product, and it's a software tool which helps you with your data science challenges. So you can basically do everything from loading in the data, you can transform your data, you can analyze it, build some prediction models, apply those models, do further analysis, visualize your data, and deploy your models. And you do all of this with a visual front end. So you can apply data science without necessarily being able to code. So you have a graphical user interface, you configure your data science application step by step, and with a visual front end. And how it looks like, I'm gonna show you in a second. And our approach is openness. So openness in different dimensions. So we're in our sense, we are integrating platforms. So you're able to integrate different sorts of data files, different sorts of data handling systems, databases. You can connect to your big data environment. And we are also open to integrate other open source libraries, for example, the H2O machine learning. But you're also able to use R and Python for your favorized packages if you want to do those. And we are also open for different kinds of user personas. So you can use the tool as a data analyst, and yeah, you can transform your data, you can come up with some metrics, you can build reports with the tool, you can use it as a data scientist to build some prediction models, apply those models, deploy those models, and you can use it as a domain expert and visualize your data, for example. And yeah, nowadays we got the biannual release cycle, so we release a new software version every half a year, and we got a lot more than 20 open source releases since then. And yeah, it's all open source and freely available. You can download it on the web and start right away. And usually when I say this sentence, people start asking me, how do you make money? So there's another product, and it's the KNIME server, which complements the KNIME Analytics platform. And how this works, I'm gonna show you with this slide. So right in the middle, the heart of the whole thing is the KNIME Analytics platform. And it comes with some core functionality. The most common things you wanna do are already in there. And then you can extend this analytics platform with some KNIME extensions. That is functionality which we mainly developed. For example, the text processing. Our developers came up and wrote some extensions to text processing. And then there are KNIME integrations you can additionally install. And that's, for example, the H2O machine learning. So it's basically a wrapper around existing popular open source libraries. Not necessarily machine learning, but also machine learning. Then we've got a really strong community, so also maybe companies, maybe universities develop functionality for the software and provide it as well as open source. And then there are some commercial extensions from partners like consulting agencies, stuff like that. And then there's the KNIME server, which complements the KNIME Analytics platform. So with the free and open source tool, you can basically complete the whole data science process, from loading the data, integrating different data sources, transform it, do the analyzation, build your models, deploy it, visualize it. And when you want to have an enterprise-grade solution, when you want to collaborate with colleagues, when you want to share your workflows with your coworkers, for example, when you want to automate stuff like your ETL process, you want to set up a schedule, let it run on a fixed schedule. If you want to manage your data science applications with access rights, for example, or versioning, all the stuff, does the server for you. And last but not least, it offers you lots of deployment options. So in the analytics platform, you defined your prediction model, you trained a good model, and now you want to deploy it as a microservice for prediction, for example. And by uploading it to the server, you can get a nice REST interface and call your workflow on the KNIME server. And yeah, do, for example, a scoring. And I'm gonna show you the basic concepts within KNIME. So I was talking about data science applications. In KNIME, we call those things workflows. And so you got the data flow, that's a workflow. And a workflow consists of nodes. And every node performs one specific task. And here, for example, we've got a partitioning node. So above the node, there's the node name, which is somewhat descriptive. So this node is going to partition our data. A node has different ports. On the left-hand side, there are input ports. On the right-hand side, there are output ports. So this node takes some data in here and partitions it, for example, in a training set and a test set to build your prediction model and to test it afterwards. Additionally, there's a light below which indicates the status of the node. So you have to configure a node here, for example, how big should the partitions be? And if it's not configured, there's a red light, so you cannot execute it. It cannot perform its task. So you go into the node dialog, set the parameters, and then it's configured. The light changes to yellow, and then it's ready to run. And if it's executed successfully, the light will change to green. And if it runs into an error, you get this big error sign and the descriptive error message, and then you can start debugging. Yeah, and by combining these nodes, by connecting those, you can build such workflows. And here's a fairly simple workflow which creates a prediction model and applies it afterwards and does a scoring. Yeah, but before or instead of continuing showing you slides, I'm going to show you the tool live right away, and such that you can get a better feeling. So this is how it looks like. That's the KNIME Analytics platform. You got a starting screen here with some pointers if you're a beginner, where you might want to start with some learning material, things like that. And here on the top left corner, there's the KNIME Explorer. So that's your workspace. There, your workflows are stored. All the work you've done is in there. And with a fresh installation, you will get a few of these example workflows here. And I'm going to show you just this one. It's a churn prediction, and yeah, we provide it as a demo workflow. And again, you see we've got many different nodes here and connected with each other, and the data flows then from left to right. And usually in the beginning you have to get your data in the tool first. So here we got some flat file readers. So we got an XLS file and a comma separated file. And yeah, we want to join them first. So there's a joiner node, fairly descriptive. We want to convert our data. We want to have a nominal column instead of an integer column here, so number to string. We're gonna color our records, all these things. And you see here lots of yellow lights, some red lights. So let's see whether we can get them green. All right. So the workflow is now executed. There's also the view, and let's see, because that's the benefit of having these workflows. You can investigate the state of your data step by step at each step of your workflow, so you can check whether the task you just performed does the proper change to the data. So you can, after each and every step, you can investigate the data behind the node. So here there's just some columns with the values in there. We join that. Here we again get another data table. We do conversion from numbers to strings here. We color code our records. regarding to our target variable. So we got two different, either churn or no churn, and we colored those records here. Here again, the partitioning node, which I introduced in the very beginning. So we set the partition sizes, and here there's the very first different thing. So you see there's a black triangle. That's the port for a KNIME data table. And what comes out is this blue square port. So that's basically a model we just created with our decision tree learner. So we trained the model. We can save it somewhere as a PMML for later use, for deployment in our existing prediction environment. Or we could use it here right away in this decision tree predictor. We use the model here via the model port. We connect the test data partition to the decision tree predictor, and it will provide the predictions and also provides the class distribution. And here we've got a scorer for evaluation. So as it is a classification, we got a confusion matrix here and some accuracy statistics. Precision, recall, overall accuracy. That's what our scorer node gives us. And then we've got lots of different ways to visualize the data. And if you want to evaluate your model, you might want to see the ROC curve. And here we got the ROC curve with a 0.8 ROC. So these are different ways to evaluate your model. And yeah, we ship these things pre-set up to as an inspiration, let's call it like that. So if you want to do a churn prediction, so you can use that as a template, for example. And yeah, we ship a very few example workflows with every installation. Additionally to your local workspace, you can have here KNIME servers. And there's always one KNIME server in there. That's the publicly available example server. So you just log in there, and then you will find lots of different examples, either for specific tasks, like here's for data access, for analytics. If you want to build a report, there are lots of different workflows in there. And there's also a folder called applications. So there you will find different use cases. For example, also this churn prediction or a social media analysis. So yeah, it gives you templates which you can adjust for your specific use cases then. All right, so we don't just want to look at existing workflows. Let's build just one fairly simple one from scratch. So we just say we want to create a new workflow. All right, so we got our white canvas here, nothing in there. And in our example workflows, we also ship some open data. So let's just take this adult CSV, and it's automatically configured as the software already knows where the data file is located. We get a preview here. We see, all right, we got column names in there, some data, and we press OK, and it says it's ready to run. Yellow status, let's execute it. It reads the data in. And here we got again the data structure behind. And what do we have in there? Among others, we got the work class as a nominal column, and we got the age. And let's do some basic summary statistics here. And now we want to investigate on the mean age per work class. So we're gonna look, okay, down here, there's the node repository. So here are all the nodes in there, and we've got lots of nodes, depending on how many integrations and extensions you've got installed. They're far above like 2,500 nodes. And now we're gonna use a group by node to compute some metrics. So we wanna do a group by on the work class, and as aggregation function, we use the mean. Execute it directly, and here we got some statistics for the different classes, the mean values of the age, right? And you may not always want to see the data in a tabular format. Sometimes it's easier to understand if you visualize it. So let's go for a visualization as well. Bar chart. Oh. froze. Typical live demo.
Is there a way to run this non-interactively, as in like through?
Oopsie. Excuse me?
Yeah, sorry. Yeah. Is it possible to run some of these without clicking the run button? Can you drive it through command line or? Through
Yes. Yes, that's possible. That's possible, and that's so for automation and event-triggered execution. That usually does the server, and then you're also independent from your local hardware, so you deploy it to the server, and then you can trigger execution via REST calls, via schedule, something like that. Some event-based, maybe you want to look up a specific directory all the time and pick up all the new files there, stuff like that.
If you want to use Jupyter Notebook now, just recently got also a package, so you come from Jupyter Notebook, call the workflow. That's quite recent. I think it came out this week.
All right. Yeah, the visualization. So here again, we're gonna choose the column we want to have as categories. So here we got the working class. We can choose different aggregation methods, but we don't want to have the accuracy. We want to have the average again and only the age. All right. So here we do not have the data table as an output, but we have these three JavaScript visualization instead. And yeah, this way we immediately see that the class of never worked is by far the one with the lowest average age. So probably, I don't know, pupils, students have never worked. So that's just a fairly quick insight by just presenting the data in a different way. And yeah, that's just a quick demo I wanted to show you. And if you want to try out KNIME, and especially if you want to try the H2O integration, as I said, you can install additional functionality via this menu. Just click here, and we've got like several stuff in there. And if you look for H2O, you're going to find the sparkling water and also the machine learning integration. Install it, and then you're ready to go with H2O and KNIME. All right, and with this, I'm going to hand over to my colleague Paolo, who's going to go into more detail about the H2O integration.
Just a quick question: what's the runtime underneath? As in, what's actually being executed under the covers, or what technology?
Excuse me?
What technology?
Java Eclipse.
Okay.
Yeah, it's an Eclipse-based tool.
So when you're running the workflows, it's a Java process that's running.
Yeah.
Yeah.
Unless it's one of those external extensions where you run, for example, Python or R, but that's like just certain nodes that you want them to run.
So how do you then scale that up?
That's what I'm going to talk about.
Okay. All right. Yeah, here you go.
Okay. So Martin gave you a quick introduction to KNIME, and yeah, we have seen what the tool is about, and you can see that we have really many nodes for different parts. So to your question, there are the big data nodes where you can connect to Spark, Hive, Impala, and other big data platforms. Or just if you want to connect to a database, right? And we try to divide the nodes in different groups, so that you have the ones they use to transform, to access data, to do machine learning models. We have the analyzing data mining nodes, then visualization nodes, and then the ones we need to deploy. For example, you want to write directly on the database what you have been processing, or to just write a file or generate a PDF. So today we are going to talk about an extension in particular, as you might guess. It's the H2O machine learning progression. So right away, we know that probably some of you are running H2O models without KNIME. So the question is like, why should we run those H2O models within KNIME? Well, the point is that we can do a mix and match, right? We know the performance of H2O models is quite good, but you also might want to use the functionality we have in KNIME that might be useful for you. So those, for example, are data wrangling, right? You have some data on a spreadsheet, some data on a SQL database, or some other in the on Hive, right? You have lots of data in a different place, and you want to put them together, and that's maybe easier in KNIME, especially if you want to have all this visual layout of what's actually happening in this huge data pipeline, right? And then you also can use those big data connectors, which give you a possibility to execute things on Spark with just using those Spark nodes we have here for you. And all of this is open source and free, which is quite powerful. Another thing is if your domain is not just a standard tabular format. So for example, if you're using text, like documents, or chemical formulas, or images, we have those nodes that you can use to process that. And when it's the time to train your machine learning model, then you feed it to the H2O nodes, right? So how do they look, those H2O nodes? Well, it's basically, you will recognize many of the models you know from H2O. So you have GLM, GLRM, gradient boosted machines, and also some other nodes that will be used to move from KNIME to H2O, and from H2O to KNIME, and also to score them, right? And to use to use them to make predictions. So basically, it's really similar to the same format that Martin showed you before, right? You have a learner node, and then a predictor node, and then a scorer node. And you have here a way to partition the data between train and test set. The only point that coming, for example, from KNIME, which is this red, the black triangle, then you're going to move it to the H2O frame format. And you also need to create H2O local context. So it's fairly easy to just create this transformation and then train the H2O models. When, for example, when you click on this node here, then you want to, for example, change all those parameters. And instead of having, for example, a Jupyter Notebook where you change the parameters in the function, you have this UI panel. And in this UI panel, you can change all the things, and it can be a bit user-friendly, that better than Python script, right? So basically, we are going to show you a more radical, it's a Kaggle challenge, right? We're going to use a Kaggle challenge to show you how you can use H2O in KNIME. So we have some, this is a Japanese chain of restaurants. So they basically wanted to predict how many visitors they would have in each restaurant. So Kaggle gives us the data to train and evaluate, and then we have some data that they will use to rank us, right, where the number of visitors is unknown. Then we also can use the reservation of those restaurants, store information, calendar date info, and basically we have lots of data to deal with to create our models. And that's, in the end, the entire workflow will look like. And right away, you can see there is a process going through, right? If you open a Jupyter Notebook, you don't see this right away. Here we have, in the first part, we prepare the data. We read the data and we prepare it. Then we train 3 models, random forest, generalized linear model, and gradient boosting machine. Then we select one, and then we finally write a module, and then we can use the modules to make a prediction on the train test, which we will then send to Kaggle to get a rank, right? So let's go through really quickly. So in here, that's a meta node. When it's a gray node, means there is more nodes inside. We double click and we get inside. Oh wow, this is okay. Of course, we are now going to go through each of those, right? We have many files which are the CSV that Kaggle provided us. We're reading all of them here, and then we do all the really boring 80% of the data scientists, right? The data preparation part. We go through the steps. That's mostly time series. There are some time series nodes. We create some feature engineering. We are not going to spend too much time here, right? So finally, we get to this point here, and we finally split between train and test. And we go to the next step, which is basically just to get this data and convert it to H2O frame. We just use those 2 nodes. It's all automatic, and then you get this yellow square that we can use for the H2O model. So we're going to train 3 of them using the all this train set, and then we're going to select one. Let's go click in one of them. Let's take the random forest to see how it looks, the model training, optimization, and evaluation. So basically, we are using loop nodes here, because in KNIME you're also able to iterate, to take a table and iterate through the rows, or to do some more complex things. So here you have the random forest regression, and here it's where it's learning what's the how to predict the number of visitors in the restaurants, right? And here we're going to predict and then compute the accuracy of those. Not the accuracy in this case, it's a regression, but some root mean square error. And then here we basically have those 2 nodes, and those 2 nodes are using the cross validation that is also available in H2O. And this means that we are basically training every time in a different fold, and this way we prevent from overfitting. And also we are also going to use the parameter optimization loop that every time we'll try a different number of trees, right? So at the end, what you get is that here you have a group by, right? This group by is basically computing the average across all the cross-validation evaluation. You have an average error, and then this average error will be also used in the end to select the best combination of hyperparameters, right? And once we know the best combination of hyperparameters, we are going to retrain the regression on the entire train set, the train set this time. And we are going to save the model in a cell. That's basically go back in a KNIME table to save the model. So we do this for all 3 models, and in the end we take the model which has the best performance, and we finally can convert it to a module, which I don't need to explain what it is, because the H2O guys already did that. And basically this really fast format will be used to make the predictions that we are going to need to have a file that we can send to Kaggle and to know how well we did, right? And here we can just save the module file, and then you can use it however you wish. Do you want to do some Python, some R, some Java? These are the configuration panel of those external tool looks like. You open them, write your script, you modify the input, you create new output, you get output. So if you really need to have that part with just straight coding, you can, right? And that's really helpful to be able to mix things that much. You're not just doing only Python or only Java, only R. You are doing all of 3, however you wish, right? Depending on the packages you need. Okay, so other things you can do. Image processing. We have all those nodes. They're able to make you do a lot of feature engineering based on the images, filters, and much more. Then that's the Keras deep learning extension. You're basically able to create that deep learning network using those nodes. Each of the brown nodes is a different layer, and then you feed it to the learner, and it will use the architecture you basically were drawing using the nodes. And each time you click on a node, you can change the settings of that layer, number of neurons and input, output, and so on. And yes, so that's for the deep learning part. Text processing, bag of words. You want to analyze your data. You want to do sentiment analysis, right? You can also use this extension to do that. Databases, you need to continuously create SQL, and you don't want to do SQL, use our nodes that will create SQL queries for you. And that's quite visual and powerful. Big data integration. So how do you scale up a really big workflow, right? You can use those connectors we have Hive, we have Spark, and we connect, and then you can use those nodes to basically parallelize to wherever you have your big data environment. So we offer those nodes, which are the in this case, we're using Spark K-means. That's the K-means machine learning from the machine learning library of Spark, and it's efficient because it's designed for Spark, right? And you can use it just like any normal node. That's a lot of Spark nodes you can use, right? And it's not only for machine learning, it's also for manipulating data. And it's important to make sure that the task is parallelizable. So if you see there is a node, then you know that it's the case that you can parallelize that process, right? So H2O sparkling water in KNIME, it's the next workflow we're gonna go through, and it's basically quite simple like before, just we need to play a bit with Spark in the beginning, right? So if we need to load the data into Spark first, we need to maybe retrieve from a Hadoop file system, right? We need to establish a web HDFS connection and create a Spark context. Then we are going to take the Parquet file from Hadoop file system, and we are going to import them into Spark using the Spark context. And then we go to the next step, and now we do this massive chunking of terabytes of data directly on Spark, always using our nodes, right? So we go through all those steps, and we join, filter tables, join different tables, and handle missing values, computing a correlation matrix, and so on. And finally, we partition between train and test set. Next step, we want to go to run this in H2O sparkling water because we have our train and test set ready. So what we do this simple conversion here. We need to create a Spark context first, then we need to create a sparkling water context, then we convert the table coming from Spark to the H2O frame using the sparkling water context, and then finally we are ready now to do the training in H2O. What does it mean? It means basically what I showed you before, because from now on it just looks like before, just that we are running things on sparkling water, which is quite smooth. We don't need to think too much. Like, as long as we have a right sparkling water connection and a good Spark context, it's going to work. So that's the training that will come up and really fast thanks to the H2O system. And then finally we select a model and then we deploy it. What does it mean deploy it? That's up to your scenario, right? The microservices and so on. That's why the arrow is back to the KNIME arrow, because that you can use our microservice with the RESTful API and so on. So how we could see it, or you could use H2O trained models in a deployment scenario, would be to use the module, right? You would do use an H2O module reader, and then you would use it for classification directly on Spark. You would use a Spark context, convert the data you have to Spark, and then run with a Spark H2O module predictor and make the prediction Spark. That's really fast scoring if you need really a lot of predictions right away, right? And yes, just to wrap up, I see someone really tired in this room. Right? So basically, we're having a spring summit soon in March. It will be between the March 18th and March 22nd in the Berlin Congress in Berlin. Monday and Tuesday, it's one-day courses. So you learn how to use all those different extensions or just KNIME. There are advanced core, beginner courses, and so on. Wednesday and Thursday, the summit sessions. Here it's quite great because you finally see people that actually use KNIME to solve a real data science problems, right? Like they had a problem and they built a workflow, they explained the workflow and see how then finally they used it. And then Friday it's workshops. So like we do learn-a-thons. We divide people into groups, we do exercise, so it's great networking and also learning while having fun. And just so you know, February 4th, it's the last day to get the 20% off tickets. And you need to go on the website to register. If you want to learn more about KNIME, we have those books. Usually we sell them online. If you want to use this coupon, maybe you want to take a picture and then you can use this coupon to download a free copy. And yeah. basically those books will guide you through the beginning of 9, right? Then there are also more books to go to the advanced version. Yeah, thank you. That's the last slide. Go ahead.
2 questions. One is, so what you showed us is the developer experience, right?
Mhm.
You use the editor, create pipelines, and you get to the end, then you click deploy.
Mhm.
What happens then?
So basically, the deploy part is really depends on your application, right? Sometimes you, what I would see is, for example, use if you need a microservices, you need a RESTful API. So the point is that when you build the model, you use a workflow, and when you want to deploy, you create another workflow where you import everything that was done. And with this workflow, you can actually have an application. If you take this workflow, for example, you put it on the KNIME server, right? Which is our commercial product. On there, you can, for example, use a RESTful API to every time predict using a RESTful API. You can, for example, that's about machine learning, right? Because it depends the deployment if you instead have a different situation. You can, for example, execute on Spark the prediction. You can have that whenever, like, you schedule it to run every Monday and to update SQL database.
But it's running on your platform? Right?
No, when in that case you are installing KNIME server on remotely on either some companies want a machine indoor, like that it's more safe, but people also use Azure or Amazon Web Service to install KNIME server there, and then from the KNIME Analytics platform they can upload or remove workflows on this remote location and run them from there.
So when you call into H2O, what you're saying is you will also have H2O deployed or Spark deployed in additional servers in...
Yeah, like in the case would be to use those modules. Probably you do all your work, you save a module, and then with the module you can deploy it however you wish with KNIME or with other tools, right? If it would be with KNIME, I would imagine with KNIME server, right? Because you can have something online all the time that is being used.
Okay. And the second question is about, I mean, some of what you showed were pretty complex pipelines.
Yeah.
Do you support scenarios where more than one person is working on different parts of the pipeline? Source control?
Yeah.
How does that work?
So that's also a KNIME server, right? You can. So basically, people can work on the workflow on the KNIME server, and basically you can have versioning, so you know how it's going on, that multiple people will do it. And also there are tools to see the difference between different versions. So basically, when we have KNIME that is free and open to use, but there are certain functionalities that really company are looking for, and those are commercial.
Permissions?
Yeah, permissions, for example, of course. So this folder is only for that team, that kind of stuff. Also, there is the KNIME web portal, so you can basically certain nodes that can create a web page. So it becomes online like a wizard. So you can upload a dataset, next, change the parameter, next, training, and then see the ROC curve, okay, download the module. So you can have like a whole visual certain web app, right, that is running on the KNIME server. Oh, wow. Okay, in the back, he raised his hand first, sorry.
So it's a twofold question actually. Can you execute tasks in parallel? And if you can do so, is there a possibility to assign these parallel tasks, say, to different servers to speed up the execution?
So when we use KNIME server, we use also KNIME executors. And we can have, we can basically use parallel executors, which is parallelize the workflow that way. Correct me? Okay. So that's cool, right? Like, so you can use just the server itself to parallelize the branches and the execution of the workflow. Yeah, sorry.
With KNIME server, are there features for automated testing to catch big changes in the model that as they go into production?
Okay, so you're asking if what kind of changes, like other people changes, or
For example, if someone deploys a radical change to the model that will break everything.
well, yeah, like you basically have a tool that when something gets changed, you can say, show me all the changes with my version, and then will light up points in the workflow when something got changed. But then right away, as soon as someone changes, you can, there are certain tools to monitor things on the KNIME server. Definitely. Your turn.
Just trying to understand the big data extension. So if I want to drive my workloads onto a Spark cluster, so like the KNIME server is controlling this.
No. The big data extension is open source. So it makes sense sometimes to have something remotely executing, but if you want to, from your laptop, run some nodes on Spark, you can do it. You just need to have all the Spark environment ready, then you create the Spark context, and then you can run the nodes.
Okay, and then back to the other question as well. So if you want to offload on your KNIME server, you want to offload through executors, are they all still running on the same server, or can you offload to other servers? Or is it the server that KNIME server is installed on you're talking about?
No, I think we can use a single KNIME server, but
you
Mark,
can
you
also
wanna
distribute the executors if that's what the question targets for. So you can have the different workflows then different machines as well. So you can also scale it horizontally.
So I'm saying, I'm just trying to understand the cost through. So if I've got one, I don't know, 8-core KNIME server, I can then use that to choreograph and orchestrate my work across a cluster of other servers.
Yes.
there was a question there.
Well, it's just related. When you say KNIME server, is it KNIME cluster or?
KNIME server is just the name of the software. So KNIME server, it's something you would install on an actual server that you keep indoor in the company, right? Or it's actually a server that you would install on a cluster on Amazon Web Services or Azure and stuff.
Yeah, my question is more like, can we add processing power by adding more units, or do we have to just calculate one unit? Like, do I need one machine with 6 TB of RAM, or can I just have a cluster of them?
You've got both options, so you can stack up in processing power by adding memory, but you can also scale horizontally by having many executors on different machines.
So universal.
Yeah.
Can you export to anything? Like, can you export to a code or script or some executable where you can just sort of?
So we were saying before that from command line you can execute the workflows, right? And now we also have this Python package to run the workflow from Jupyter Notebook, right? So you would have the workflow ready and all, but you're asking to create the workflow, like, or to the workflow is already created.
So, I mean, I'm just thinking about working with, like, if you have mixed teams, because I'm guessing this product is more so for people who can't code. But if you're working with other teams that...
Yeah, I see the point. Like, yeah, the KNIME is making data science more accessible for people that... But it's also different, because I think when you have, like, a boss, you need to show a lot of work. Workflow, like, people are, like, you need to have trust of the work you did, right? So the workflow, when you show it to someone, people will trust it more than a bunch of script. That's it increased transparency, right?
Yeah.
But like to do KNIME with just coding without an analytics platform, I don't think it's something we really thought of, because we aim to give people that transparency and intuition. And just imagine you get hired in a company and you have bunch of Jupyter notebooks from the guy that was working before you, and you need to go through all of them. Like, and his coding sucks, right? In that case, it's a pain, right? Like with workflows, we're trying to make that smooth. So, but again, like once the workflow is done, you can also from command line, Python, Jupyter Notebook, you can execute it. Okay, we made it.